Welcome back. We are going to start ArcGIS ArcMap 10.4, and then we're going to use the Python window today. Open the Python window. So the Python window is an interactive Python interpreter and allows you to run Python code directly from within an ArcGIS for desktop application. So Python window. All right. And we started ArcMap, and on the Start Standard toolbar, we click the Python window to open the Python window. As with other windows in ArcMap, you can leave the Python window floating or dock it on any side of the ArcMap interface because you will be typing horizontal lines of code. It makes sense to dock the window as either the top or the bottom of the interface. We're going to dock the Python window, drag the top bar of the Python window. This brings 8 arrows forward, which are visible here, indicating the various location where you can dock the Python window. And we dock the Python window on the bottom row, so the window at the bottom of the interface. So I don't like it. I still like floating. If you want to undock the window, we can just drag the top bar again, and the Python window itself can be resized, and you just go to the corner and you can resize it, and the divider between the code section and the help and the syntax panel can be moved. Placement of the help and syntax panel can also be controlled, and we can right click on the window and click help placement, help placement bottom. Okay. Alright, we can drag the divider between the code section and help syntax panel to adjust their sizing the way you like. There. Alright, we can now write and run code as in any interactive interpreter. Python code is run one line at a time, and the results are printed immediately. So we're going to type the following. So we can do some simple calculation. We name A defined to 12, B equals 26, and A times B equals 312, A equals 1, and B equals 16, A plus B equals 7. Alright. So, whether you use places here or not does not influence the execution of the code. That is, A equals 12 is the same. If you put any space anywhere, it's the same. Spaces are commonly used in Python to make code easier to read, but are often not required. So it's better you do A space equals 12, and then B space equals 16, and A space times B there. So after you plus enter, the line of code is executed, and the next line automatically starts with a new command plopped. The result of the preceding code is here. So we can also try something different. At the command prompt, we're going to type the following. So if A space and smaller than B, and alright, so we hit enter to run the line code. The result is a secondary prompt at the next line consisting 3 dots. So this means that the interactive Python interpreter recognizes the start, the multi-line construct. The if statement is the first line of a block of code, and at least one more line of code is needed for the code to run successfully. So Python window automatically indents the next line of code. So at the secondary prompt, 3 dots, we enter the code because this is the block of the code following if statement. The code has been indented. So this indentation was not automatically in ArcGIS 10 and had to be added manually by typing 4 spaces. So actually right now it's indented. He enter, but now it's indented. Okay, print A is less than B. Oh. So at the end of the line of code, we're going to press enter and notice the result that the line of code is not executed, and the next line starts with another secondary prompt. So within the pointer at the start of the next line of code and without entering any code, so we're going to print enter, and it printed for us. So when you are working with a secondary prompt, the code executed only when you press enter twice. So this runs all line of code following the last primary prompt. So the Python window provides the secondary prompt automatically when it recognizes a multi-line construct. However, we can also force the secondary prompt by pressing Control Enter. Let's see. Control Enter, Control Enter. Cool. Alright, and we're going to right click the Python window and we can just clear all. So, and now this is showing back. So at the primary prompt, we're going to type the following. Code is x equals 1. And then I'm just going to clear everything again. Clear all. Okay, x equals 1, and then Control Enter. There. So if we hit Enter and it gives us the prompt, the 3 greater sign, but at the end of the line of code, I pressed Control Enter. This brings up the secondary prompt. We can keep entering lines of code and pressing Enter at the end of each line. So the secondary prompt continues to appear and the code is not executed until you press Enter twice. So I'm going to enter. Now it's not working. Enter and enter. There. So at the secondary prompt, we're going to, no, you cannot delete it. You can just clear all. X equals 1. And then we're going to y equals 4. Y equals 4. And then, print. And x, I forgot z equals 3, and print x times y times z. There, it's 12. Alright, so now let's see, x equals 1, Control Enter, and y equals 4, enter, and then z equals 3, and Control Enter, and print x times y times z, and then hit enter and hit enter again. So the difference is when you see the 3 dots, you have to hit enter twice for the result. There is no need to enter spaces here following the secondary prompt. In an early example using the secondary prompt, spaces were needed to create a block of indented code, but this is not the case here. All right. So at the end of the last line code, we had enter twice. So if you use enter plus control plus enter, makes it possible to complete several lines of code before running it. As you were typing print and if statement, you probably already noticed the code auto-completion prompts. So next, we will take a closer look at how this prompt works. And we're going to right-click on the Python window and clear all. And at the primary prompt, we're going to type text equals GIS. Text equal GIS. GIS. And then the next line we're going to start print. So as long as you start typing the letter P, so let's go back P, and then you can see there are prompted by a list of suggestions. These code auto-completion prompts include any text that you will be logical based on Python syntax. In this case, there are two Python statements that start with the letter P. We can select the option you want to use your pointer by using the up arrow and down arrow keys. So we select print statement. So I'm going down and then hit enter and then press the tab key. So I didn't do the tab key, so print P and tab key. All right, so I selected tab key. And for a statement as short as print, using the prompt does not save much typing, but auto-completion prompts can be very helpful as reminders of the proper syntax, and they can help you avoid making typos. So after the print statement, we're going to type a space and followed by letter T, and then notice that the list of suggestions is not limited to building Python terms, but also include text, since it was used earlier in the code. So the term text is a variable here, a term that is covered later. Variable. So we're going to select text variable and press tab key. All right. And then we hit enter to run the code. So it's worthwhile to note that you do not have to use the code auto-completion prompts instead of selecting one of the suggested terms. We can simply continue typing. You can also turn off the prompt by clicking in the Python window and selecting or clearing the showing default choices option. However, we can benefit from the code auto-completion prompts because using them reduces typos, makes writing code faster, and shows all of your options in the drop-down list. We have already seen how to clear code. Right-click in the Python window and clear them all. And however, we can just continue run lines of code, and the window will start to roll downward if the lines of code do not fit in the window. Also, clearing the lines of code does not refresh the interactive Python interpreter. Rather, the code executed earlier is still in memory. All right, we're going to right-click. We already did right-click on the Python window and clear them all. So at the primary prompt, we're going to print text. And notice that the code printed the correct text as shown in the figure, even though the lines of code are no longer available. So we closing and open the Python window does not remove the code, nor does it remove the code from the interactive Python interpreter. However,